Here's a third question. The data in the table represents the ages of the winners of an award for the past 5 years. We want the mean. Get this to move. All right, let's do this. I'm going to open this up in Excel to get that average. Take a moment to open. Okay, here we go. So the mean for that small population of 5, typing in the 6th row, type equals the average of, oh, that was no good. Let's try that again. Equals average of what's in column A, row 1, down to column A, row 5. I also suspect that they want the standard deviation of the population. So equals STDEV. Notice that we've got 2 options here. And I'm going to go with .P. And I need to tell it that that also was for column A, row 1, down to column A, row 5. Now, I may revise that shortly, but let's see what they're asking for and what they're telling us. I believe that's meant to be a small population of 5. Okay, they are talking about a population, small population of 5. We had that the mean was 53 and 6.9857 approximately. So let's see here, 53. Okay, that's good. Okay, for those of you that have dealt with section 5.5 in this textbook, or if you're using a different textbook, then you would, if you have learned about the multiplication principle of counting, about factorials, permutations, and combinations, you can see that from a small population of 5, that there would be 10 samples of size 2. 56 and 45, those are 11 apart. Halfway in between would be 5.5, so our sample mean would be 50.5. 45 and 46 are only 1 apart, so 45.5. 56 and 54 are 2 apart. Halfway in between is 55. These are 19 apart, so 9.5. 10 apart. Halfway in between, 5 more than 46 or 5 less than 56. These are 8 apart. Halfway in between, 50 is 4 apart from each of those. And this is all stuff that you can be putting in the calculator, add the 2 and divide by 2. These are 8 apart. 10 apart. 9 apart. And 18 apart. See how I did? Construct a sampling distribution for the mean by listing all the sample means and their corresponding probabilities. Let me think for a moment here. I could be way off here, but let's try this. The first sample mean that I came up with was 55. That's showing up twice out of the 10. So 2 out of 10 or 0.2. The next one I came up with was sorry. Not sure about what order they want this in. So if I put the 50.5, that only showed up one time out of the 10. So 1/10, 0.1. Then we had the 55. That was showing up twice. '51 only showed up once. E60 only showed up once. Because there were 10 samples of size 2, I'm dividing all of those by 10. 49.5 only showed up once. Sixth one was 45.5. There's only one of those. Then we had 54.5. There's only one of those. Eighth one was a 50. There's only one of those. Ninth one was a 59. We're not seeing that anywhere. Now, I think since we've already accounted for 55, we want to put this. Instead of listing that again, we've counted the 2 of them here. So I'm putting N for no solution there. Not sure if that's what they want or not. .5, they've got a 0.1 like I do. 54.5, they've got a 0.1 like I do. 49.5, they've got a 0.1 like I do. 55, is that my error? 55, they've got a 0.2. Okay, so another issue, I neglected the directions here where we were supposed to be going up, but also where I had the 0.2. Well, I did have that part right. Okay, so it wasn't in ascending order. That's definitely a problem. If I add up all 10 of these, then we've got 45.5 plus 49.5 plus 50 plus 50.5 plus 51, oh, 50.5 plus 51 plus 54.5. And then I'm going to put twice the 55. I can either add 2 copies or just do that multiplication. And then 59 was 0.1. And 60 was 0.1. Those of you that have dealt with chapter 6 in this textbook or have learned about finding the mean of a discrete random variable, I could have multiplied each of these by the probabilities. In my case, the way I did this, I have to divide by 10. I'll get 53 when I do that. Checking that I added correctly. Well, the mean of the population was 53. So the mean for the sampling distribution of X bar is also 53. So what's the probability the sample mean is within 2 years of the population mean age? So from 51 to 55, got 0.1, another 0.1, and 0.2. Adding those up, I would have 0.4. Okay, let's see what's left to do. Should just be one more example.